Good morning, guys. Happy Thursday. I know that you've been working so hard this week and we've been super impressed with your work. And yesterday you were continuing with simplifying mixed numbers. Now, a few of you, I think, still got a little bit stuck. And if you have a look at today's PDF, you'll see that I put a link to a page that helps you go over some of that stuff all on simplifying fractions. And I hope you get to enjoy some of the games and videos there. But also, some of you were telling me that you're confused about improper fractions and mixed numbers. So today we're going to be looking at that in a little bit more detail. After you've watched all the slides, go back to our PDF today on class stories and you can see the work that we want you to complete independently. Best of luck, don't stress, you're going to be amazing. I thought it'd be a good idea to just start by going over a few things. Now, as you can see up here, let me just get my laser pointer ready. Ooh, very fancy. I want you to look and think about this word, proper fractions. Now that's a tricky concept when it comes to talking about maths and fractions, but if we just have a little look at the slide here, I'm sure we'll be able to break it down. So basically, I want you to have a look here at this fraction. Can anybody recognize how I'd say that fraction? Lovely. We would look at that fraction and we'd say that represents 3/4. Now, there's a little arrow here, and we know over this time we've been studying fractions that the top number is known as the numerator. And this shows us the number of pieces we have. Now, we can see over here that this pizza, we can see that we've got 1, 2, 3 pieces of pizza. Now we have to look for some more clues to the next bit of information. We're going to be looking at the number down below, also known as the denominator. I love that Miss Gawley always refers to it as the demons, and I just think of kind of flames and hellish ghouls and demons pointing up from there. Anyway, the denominator, it shows us the number of parts we are dividing by. So let's think about this pizza now. If I were to then switch to my pen, we know that really this pizza is made up of 4 slices. The denominator has told us that. That's how many parts we are dividing this pizza by. And this numerator above is showing us that we have 3 out of those 4 slices. Now, the thing to remember when it comes to proper fractions is that a proper fraction is where the numerator, the number above, is less than the denominator. Hoping that you're able to recall what proper fractions mean. Now let's have a think about what we can guess improper fractions mean. I'm just going to then put that there. So we're going to realize that it's actually the opposite of a proper fraction. It's not proper, it's improper. What does that mean though? So let's have a look at this fraction here. How would I say that fraction? Any ideas? Now, if I read that, it's probably most likely that you'd be able to say that that's 7/4. But it's a bit tricky because it doesn't kind of roll off the tongue in the same way, and it might look a little bit strange to some of you. Now, just like we learned in the previous slide, the numerator, the number above 7, is telling us the number of pieces we have. And you might look at the image over here and you can see that we have 7 pieces of pizza. And the denominator down below is showing us the number of parts we are dividing by. We know that each pizza is divided into 4 equal parts. However, an improper fraction is where the numerator, the number above, is greater than or equal to the denominator. This happens because you have a whole or more than a whole. So let's think about that. If I were to look at this fraction now, how many whole pizzas do I have? Any ideas? Brilliant. I've got 1 whole pizza. And now how many slices do I have of this second pizza? Any ideas? Brilliant. So you can see we've got 1 whole pizza and 3/4 of that second pizza. We've now just shown that we've made an improper fraction into a mixed number. Sorry guys, that last little clip cut out at the end, so you missed what I was saying. I just wanted to go over that and make sure everyone was very clear. So in the previous slide, we learned that we were able to convert an improper fraction. Can you remember what an improper fraction is? Fantastic. When the numerator is greater than or equal to the denominator, we were able to transform that into a mixed number. So we started off with 7/4, and you can see that that is equal to 1 3/4. Let's see if we can have a go at converting this improper fraction to a mixed number. So I'm just going to get my pen ready. As you can see here, we've got this fraction that's been given to us. We've got 8/5. Now there's a little kind of bar image on the right hand side which should be able to help you work that out. So we can see by the top bar that we have got 1, 2, 3, 4 and 5 of those 5 parts shaded in. So 5/5 have been shaded in on that top bar. Let's have a look at the second bar. We have now got 1, 2 and 3 out of those 5 parts shaded in. So altogether we have now represented that there is 8/5 shaded in. But how am I going to convert that to a mixed fraction? Well, let's have a look at that top bar. Because we know that 5/5 have been shaded in, we know that 5/5 is also equal to 1 whole. So we would then write that as the number 1. How many fifths have been shaded in out of this second bar? Any ideas? Brilliant. We can see that we have shaded 3 out of the 5 bars. So you have now converted that improper fraction of 8/5 to the mixed number of 1 3/5. Well done. Let's see if we can have a go at a second question. How are we going to convert this improper fraction to a mixed number? So here we can see this fraction is telling us that we are trying to convert 11/10 into a mixed number. Now on the right hand side you will see 2 bars, and both bars have been split into 10 equal parts because that is what our denominator is telling us to split them into. However, we don't just have 10 of those 10 parts to worry about. We've been told by our fraction that we've got to think about 11 of those parts. So if I were to partition 11, we know that we could partition that into 10 and 1. So that's basically telling us, first of all, we can safely cross out all of this first bar because we know that 10/10 is going to be equal to what? Any ideas? If I shade in 10 out of my 10 top bar, what could I make that into if I was trying to simplify it as a number? Brilliant, well done guys. You'd be able to write that as 1. 1 whole of the bar has been covered in because 10/10 have been shaded. However, we're not just dealing with the number 10, we are dealing with the number 11. So that means on the second bar, I now need to shade in how many tenths on that second bar. Brilliant, I need to shade in 1 of those tenths, because that would mean I've shaded altogether 11/10. And how am I going to convert that into a mixed number? I've got 1 whole and, lovely, 1/10. Good job everybody. Now that you've been shown a couple of questions and how to work it out, I'd like for you to now pause this video in a moment and try and work these 2 improper fractions out for yourselves. Make sure you show your workings out, and if you need to draw your bar models, please do so. Off you go guys, best of luck, don't stress. Okay guys, let's go through the answers, hoping you got on well and that you're feeling super confident and happy that you've managed to grasp this very tricky concept. So we start off with the improper fraction of 6/4. We know that we have to then shade in, or shall we say cross out, 6/4. So I'm first starting off with my top bar. So 4, 5, 6/4 have been crossed out. The top bar has shown that 4 out of those 4 squares have been shaded in, and we know that that is equal to 1 whole. What about this second bar? How much has been shaded in? Brilliant. You might have recognized that 2 out of those 4 second bars have been shaded in. Is there another way that we can simplify this even further? Have a look. Brilliant. We can actually see that in fact 2/4 is equivalent to 1/2. Well done guys. Either or, I'd accept both answers, so not to worry. Fantastic. Right guys, this is our last one before we start going off and doing some of our independent work. So let's see how you got on with converting this improper fraction to a mixed number. So we've been told that we've got 14/9. So the top bar has been split into 9 equal parts. So I'm going to first of all cross out 9 of those parts. Oops, sorry. Again, some of my crosses are very wibbly wobbly, guys. Now that we've got 9 of that top bar crossed out, we need to cross a few more so that we have 14/9 crossed out. So that would give us 10/9, 11/9, 12/9, 13/9 and 14/9. Brilliant. So I've now crossed out 14/9. How am I going to convert that to a mixed number? Let's look at this top bar. We know that 9 out of those 9 squares have been shading in. So that equals 1 whole bar has been shaded in. What about the second bar? How many ninths have been shaded in on that second bar? Fantastic. 5 out of those 9 bars have been shaded in. Therefore, you managed to crack this and work out that 14/9 as an improper fraction would be converted to the mixed number of 1 and 5/9. Brilliant work, guys. Well done. Okay guys, well I'm hoping that now you've watched the whole of the lesson presentation that you're feeling a lot more confident. Please now head on back to our class stories, click on today's PDF work file, and you can scroll down and have a look at the work we'd like you to complete. I know it's really tricky because we don't have our Maths No Problems 4A workbooks at home, but I've been really impressed. So many of you have been copying out the questions, showing your full workings out and giving your answers clearly, especially if you're not going to be using a printer to print things out. Best of luck. I'm here if you need me, and I know you can do it. Have a great day.